Section 3.3 is analyzing the graph of a quadratic function. So we know what it looks like. A quadratic is that ax squared plus bx plus c, where we know it's a parabola. But depending on what form they give us, the equation, we'll be able to graph it. So here we know what it is because we can tell by the shifts. This minus h, we shifted it left or right depending on what h is, right? And then plus k, we shifted it up or down. So we have an idea of what it looks like. So what I wanted to point out, guys, is the graph is a parabola, but the point hk comes from here, these two things, and that's your vertex, okay? So the vertex is that main point, kind of like that pivotal point where we go from decreasing to increasing and vice versa. And again, you just think, okay, I shifted left or right. I shifted left, so my h is a negative. I've gone up 2, so my k is a positive 2. So what we want to realize is anytime we graph a parabola, that vertex is either a maximum or minimum depending on whether the graph is opening up or down. So that's just what the next sentence says. So the maximum or minimum is always at the vertex. So that we'll kind of circle that. The maximum and minimum are always at the vertex because it's either the highest point or the lowest point. And the last thing that we are kind of introducing in this section is the axis of symmetry. And just realize the axis of symmetry, guys, is right here. It's the x value from vertex. So those are going to be kind of some things. We're first going to ask, what's your vertex? What's your axis of symmetry? And then do you have a maximum or minimum value, and what is it? Okay? So let's look at these couple examples here. So this first one has a plus 3. So we know what kind of shift that was. That was shifted in which direction?
To the left.
Left 3, right? So what's the x value for its vertex? Negative 3. So notice that vertex down here is negative 3. This minus 2 has shifted our graph down 2, right? So notice that's the y value or vertex. So our vertex is negative 3, negative 2. Now looking at that graph, is that the lowest point on the graph or the highest point on the graph?
The left.
The lowest. And so then it's a minimum value of that y. So remember, the minimum or maximum is always the y value. Where it occurs is the x. So you would say there's a minimum of negative 2 at x equals negative 3. All right. See if we can get the same. Oh, and another thing I want to point out, sorry, is that axis of symmetry is what goes right down the middle of our graph. If we were to fold it on that axis, like if it was the y-axis or x-axis. So notice your axis of symmetry is always x equals whatever your x value is there, okay? It always matches your x value of your vertex. So looking at the middle graph, minus 1 means we shifted it to the right 1. So notice our vertex x value is 1. Plus means 3, we mean it shifted up 3. Again, though, notice it's a minimum value because it's the lowest point of our graph. So we would say we have a minimum of 3 at x equals 1. And then again, notice that axis of symmetry, that 1 matches the x value of our vertex. Last but not least, what we have here, why do we know it opens down? Is we're going to kind of talk about this, guys, is that it has a negative a. Negative a opens down. Okay, so if you remember, a negative on the outside means we're multiplying our y values by that negative, meaning if they were positive, they're not going to go negative. We reflected about the x-axis. So by knowing that's a negative a, we know it's going to open down, meaning the vertex is going to be the top, and it now is a maximum value. So notice here, our 1, 3 is the top, so it's a maximum value of 3 at x equals 1. All right, so all we're going to do is they're going to give us a function now, and we just have to label all these points, all right? So let's look at example 1. It wants us to find the vertex, then state the axis of symmetry, and find the maximum minimum of the value. So let's kind of talk about what's happening. What's this minus 4 do? What?
That means it's moving it to the right.
Right 4, perfect. What's this minus 2 doing?
It's going down 2.
Down 2. And I don't necessarily care about the 3 as much as I care about the sign of the 3. We've reflected about the x-axis, right? Meaning we are now opening downward. So we don't have to draw a perfect picture, but let's kind of just sketch it, guys. So we're going to go to the right 4. 1, 2, 3, 4, and down 2. 1, 2. So this is going to be like our vertex right here. 4, negative 2. Is that okay? And again, just kind of sketch it. We know it's going to be a parabola, so it's going to kind of look like that. All right, so what we're going to be able to do, I'm just going to kind of number them on the right-hand side of this area. Number 1, let's find our vertex. Well, you basically told me the vertex when you told me the shifts, correct? Your normal vertex, if we have not shifted, is at 0, 0. So since we shifted it to the right 4 and down 2, we know where our vertex is. We couldn't graph this if we didn't. So does everybody agree that it's 4, negative 2 as our vertex? The axis of symmetry is really honestly the only new part of this so far. So our axis of symmetry is an equation. So they do want x equals. But it's always just kind of what goes right down the middle of that parabola. Well, that's a vertical line, so it's x equals whatever that x value is of your vertex. So what x value are we at? 4. And then 3, do we have a minimum or maximum? Well, since we're opening down, we have a high point, correct? So we have a max of what? Well, whatever the y value is at x equals 4. So this is always the y value. And that's really not anything new. When we did our, I don't even remember what section it was, in chapter 2, I think, when we did increasing, decreasing, and so forth, we talked about maximum. So it's the max is the actual y value. So we have a maximum of negative 2 on this graph, but it's happening at an x value of 4. Is that okay? So the only thing that we're going to do is, like, this is not bad if we're given, this is called the vertex form, where we can see our vertexes right here, h and k. We can tell what the shifts are. If a is positive, this is kind of what I was talking about, the graph opens up. If a is negative, the graph opens down. And so that's where we get the idea of, whether it has a max or min. But what if we see the quadratic, and this is called the standard form, that ax squared plus bx plus c? What do we do with him? Okay, so let's flip it over to the top of page 2 to see what we need to do. So how we find our vertex whenever our graph is in the standard form is we find the x value always by this formula, negative b over 2a. So he kind of looks like the quadratic formula. You know how the quadratic formula is negative b plus or minus all that jazz all over 2a? This is the first part of the quadratic formula, the negative b over the 2a. Then how do we find the y value? So this is just the x, okay? So that's the x. How do we find the y value? We plug it into the function. Plug x into function. So the only formula we really need to memorize is the x, negative b over 2a, because once we get x, we can just plug it back into our function and out will pop y. That's the whole idea of function. So we don't actually have to put it in vertex form ever. We can just steal the vertex from this formula. So what we're going to do is answer everything. This basically mimics your MyMathLab exactly. So part A is find the vertex. So what we're going to do is we're going to find x first. And according to that formula, it's negative b over 2a. Well, what we can do in our function is we can label a, b, and c. So a is 1, the b is the 10, and the c is the 23. Is that okay? So we will have what? Negative 10 over 2 times 1. And just be careful. Make sure you do order of operations. So like I don't throw it in my calculator exactly like this because it won't do order of operations right. I clean up the top, clean up the bottom first, then I divide. So leave negative 10 as negative 10, but what will the denominator just be? 2. And then what's negative 10 divided by 2? Negative 5. So that is just the x value for the vertex. So in order to find the y value, we're going to find f of negative 5, meaning, hey, I know my vertex is located at negative 5. Let's plug in the function and see what my y value is there. So just be really careful. What we're going to do, we're going to plug it in for x, but we're going to put parentheses around it. So it's x squared, negative 5 squared, plus 10 times x, negative 5, plus 23. And guys, you can honestly just put it in your calculator exactly like that. Negative 5 squared plus 10 times negative 5 plus 23. and we'll get our y value. So then, therefore, we'll be able to put it all together and get our vertex. It is, okay, and some of us can do it in our head. So we'll have 25 minus 50 gets us to negative 25, and then plus 23 more will get us to negative 2. So you just put them together. What was our actual vertex? Negative 5, negative 2. Is that okay? So negative b over 2a is the new thing that we need to start kind of thinking about. All right, part B. We have to determine if this function x squared plus 10x plus 23 has a maximum or minimum. So what we don't have to graph it. We just have to think, okay, what direction is it opening? Remember, your opening depends on your sign of your a. Even if it's in this form, it doesn't matter. If your a is positive, we're opening up. So I'm going to just kind of sketch that real quick. If our a is positive, we're going to open up. So the vertex is technically going to be what? A max or a min?
Minimum.
A minimum, okay? So the minimum's just going to be that of our y value. So this is a minimum value. Minimum of negative 2 at x equals negative 5. But they really just want that. Is everybody okay with why we know that graph's opening up? Because at a, you just look at the very first sign what's in front of your x squared. All right, find the range. This is what's interesting. So I know I didn't really graph them fully, but I am going to label this vertex negative 5, negative 2. So I have an idea of what the range is. Remember, domain was left to right. So parabolas, domains are always negative infinity to positive infinity. We're like going up and over forever or down and over forever. So we're going left to right no matter what. But your range starts and stops at your vertex depending which direction you are. So your range is always the lowest value to the highest value. So if we have a minimum, guess what that minimum is? The lowest value for our range. So what is the lowest this parabola goes? Negative 2. Is he included? He sure is. So what are we going to have for the range? A bracket. Do you remember doing brackets? And then he's going to go up forever. So how do we show he's going to go up forever?
Infinity.
Infinity. And we never hit infinity, so we'll have a parenthesis. So your range will always either start or end with that y value of your vertex. Because he's always either the start, or if he's upside down, he's the top. All right, so the last thing, again, kind of looking at our little sketch there. So our sketch isn't perfect, but it gives us an idea. We need to talk about function where it's increasing or decreasing. So he's increasing on what interval and he's decreasing on what interval? Well, let's look at this. From left to right, he's decreasing here, and left to right, he's increasing here, correct? So, again, you're going to start and stop increasing and decreasing at the x value of your vertex, right? So where are we increasing the right half of our parabola? Do you guys agree that from here to here we're going up? This is the increasing part. So where does it start? At negative 5. Use a parenthesis because even though negative 5 is on the graph, you don't know whether at the point negative 5 you're increasing or decreasing, right? You're kind of the midpoint. So it's not included. So anytime you're doing increasing or decreasing, it's always open intervals with parentheses, all right? So we start at negative 5 and then we increase forever, correct? So we're going to go to infinity. So once you get 1, the other one's just the flip-flop of it, right? Where are we decreasing, starting way over here and stopping where? At negative 5. So where are we decreasing? We're starting at what, technically? Negative infinity. And where are we stopping? Negative 5. And again, negative 5 is that start and stop point, so we don't really necessarily know whether we're increasing or decreasing right at that point, so we won't use a bracket there. Okay? So notice your range is based on your y value of your vertex, but the increasing, decreasing intervals are your x value of your vertex, which is kind of tricky. All right, we're just going to do the same thing, but with a different function now, okay? So our a is this negative 1, our b is this 14, and our c is this negative 47. So what you need to just remember is the negative b over 2a. So the x value is negative b over 2a. So in this case, b is positive, so we'll have negative 14 over 2 times a, which is negative 1. But that's just going to be negative 14 over negative 2. Yep. And a positive 7, right? So how do we find our y value? We find our y value by just plugging 7 back into our function. But be careful when you plug him in, he's not part of that negative. Like the negative is not part of the squaring. So we're actually going to square the 7 first, then multiply by negative, and then go ahead and do it. And like I said, as long as you type it like that, or write it like that, and type it into your calculator, you should be good. Okay. What do you guys get when you do all that math? Two and a positive 2, right? So our vertex ends up being positive 7, positive 2. So we have to decide, just kind of roughly sketch the graph, which direction it's opening, and label the vertex to decide if there's a maximum or a minimum. And then once we have that sketch, we'll be able to determine our range and our increasing and decreasing parts. So when I sketch the graph, is this parabola going to be opening up or down?
Down.
Down. Why do we know that?
Because the A is negative.
The A is negative, right? So that's a reflection about the x-axis. So we're just going to kind of sketch this guy just real quick. He doesn't have to be perfect. And we'll label him 7, 2, right? So if he's opening downward, because our A is negative, does he have a maximum or a minimum value? Max, right? He is the high point. What is that maximum value?
7 or 2, yeah.
2. That's what's tricky. So max or min are like y, how high or how low, or how high or how low. Where it's occurring is the x. So this is a maximum of 2 at x equals 7, right? So they want to know this part. Is everybody okay with y opens down, that negative A? All right, so find the range. Remember, range is low to high. So what's the lowest this graph goes?
Infinity.
Yep, but technically since it's down low, it's negative infinity, right? So we'll have negative infinity. And where does he stop? He stops at the vertex with the y value of 2. Do we include 2? Yes, because domain and range are what points are included. So that we go up to 2 and we include 2 for range, okay? Now it's those increasing and decreasing where we're like, ooh, at that one point I don't know what we're doing, right? But range is just what y values do you cover? We cover all of them, including that y value of 2. All right, so on D, we have increasing, decreasing. But again, just look at your little sketch as you move left to right, where are we increasing on the left half, right? So where do we start increasing? Way over here, which is technically what? Negative infinity, and then we move our way and we stop at 7, right? And at 7, we can't really say what we're doing, so we're just going to use a parenthesis there. Decreasing starts right there at our vertex. So it starts at 7 and goes until what? It's going to be positive infinity because we're moving to the right. I know, so it's really hard. So all of it has to do with the vertex. And really, we're always focusing on the y if you think about it. Like we're saying, okay, our y's are getting bigger, bigger, and bigger, our y's are getting lower and lower and lower. But it's from left to right that gets weird, like you're increasing or decreasing on what chunk of the graph. So we're increasing on this chunk of the graph, which is left to right, negative infinity to 7. And then we're decreasing on this chunk of the graph. Even though the y's are going to negative infinity, your x's are going to positive infinity. So these are always x values, and this is always y values. Okay? So your range is always the y values, but your increasing or decreasing chunk are always x values. All right, so why do we care about this? Like, what's the point? Well, a lot of things in real life actually have a parabola or a quadratic that represents it. Like profit is a quadratic function, area is a quadratic function, and so forth. So if you want to maximize profit, or if you want to minimize cost, you just find where that vertex is, and that will tell you what you need to sell or not sell in order to maximize or minimize stuff, okay? So this one is a landscaper has enough stone to enclose a rectangular koi pond next to an existing garden wall with 24 feet of stone. So he has 24 feet of stone. If the area of the pond is given by the function a of x equals negative 2x squared plus 24x, where x is the width, what dimensions of the koi pond will yield a maximum area? What is that maximum area? So the second you see a quadratic and they ask for a maximum or minimum, that should be like flashers, woo, 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 warning signs. I need to find the vertex, okay? Because what will yield that maximum area will be the x values. And what the maximum area will be, that's your a of x, your y value. So we need to find the vertex. What's another way to know that? Well, what direction is this quadratic opening, up or down?
Down.
Right? It's a negative a, which means it opens down. So, again, think about this. This is supposed to represent all of our area. Where's the maximum area occurring? At the vertex. So that's kind of another way to think of it, okay? So we need to find the vertex, because once we find the vertex, that x value will represent the width we need to make this pond in order to maximize the pond. And then when we plug it back in and find that y value, that will be the maximum area, okay? So x, that's okay. Our c will just be 0, but we actually don't use them in our formula. So that's okay, right? So our vertex, or x, is going to be negative b over 2a. So we'll have negative 24 over 2 times negative 2. Is that okay? So we'll have negative 24 over negative 4. Which will give us what? 6. And what we want to realize is that's going to be part of our answer, because if you go back to the question, it says, what dimensions of the koi pond will yield a maximum area? We know this will be the width for sure. So we want a width of 6 feet. All right, so what is the maximum area? It means what is the max. Remember, that's your y value. So let's plug y in. So we'll find a of 6 to see what that maximum area is going to be. So we'll do negative 2 parentheses 6 squared plus 24 6 and do that math. What do you guys get when you plug that in?
72.
Yep, 72. And since it's like a word problem, area is feet squared. Okay, so how do we answer our question? So this is the max area. So we have 2 questions we have to answer. What dimensions will give us the max area, and what is that maximum area? Okay, so let's think about the dimensions. Dimensions just mean length and width. And this one, I stole and I gave you the quadratic function. Actually, how you're supposed to do it is you're supposed to like make the function yourself. Remember, we kind of did ones like this, but I just gave it to you. So we already found the width, because the width, if you read up here, the width is x. X is the width of the pond. And didn't we just find x? We sure did. So what does the width need to be of this koi pond to maximize the area? 6 feet. What we were not given is the length, but we just have a little bit of a fill in the blank. How do you find the area of a rectangle? Length times width. So if you know you have a width of 6 and you have an area of 72, how do you find your width?
You divide it.
You divide it and you get a length of
12.
12. Is that okay, guys? So 12 feet is what that length would need to be so that when we multiply the 2 dimensions, we would get that maximum area, right? So the maximum area is the 72 feet squared. So that was taking 72, or max area, divided by 6 to get the 12 feet.